Ladies and gentlemen, welcome back to Mr. Lee Physics class. Today is the first day of the Pdpr MCO 3.0. Ladies and gentlemen, today we're still in the topic of electric, where what we'll learn about the subtopics today is electric potential. The aim of today's lesson is to understand the electric potential. Objective for this lesson. In this lesson, students define the electric potential V. Second, derive the expression for the electric potential at a point in the electric field due to a point charge. Objective 3. Understand the meaning of equal potential surface. Objective number 4. Use the relationship between E equal to negative dV over dr and U equal to QV. And last objective is deduce the resultant electric potential due to a number of point charge. Assume prior knowledge. Students should be familiar with Coulomb's law. 2. Electric field strength due to a point charge and due to a charged sphere. Number 3. Newton's second law of motion, where F equal to ma. And finally, integration of the inverse function of R. Ladies and gentlemen, let's look at the first slide, introduction. Observe the point charge in the electric field. So the electric field, in the electric field, the positive charge or any charge will experience an electric force and it will move to certain direction. So let's go to the next lesson. In this lesson, you will learn the meaning of electric potential U, the definition of electric potential V, to derive the expression for the electric potential due to a point charge and a charged sphere. Next, the meaning of equal potential surface. And next, the relationship of electric field strength E equal to negative dV over dx and the electric force where equal to negative du over dx. Finally, to describe the motion of a charge in an uniform electric field. Ladies and gentlemen, let's go to the next slide. Observe that there is a positive charge in the electric field where this plate is charged with positive charge. If positive charge, that means that the electric field is going up. So this means that the direction of the electric field is to right. The direction is to right. And how about the positive charge? When the positive charge in electric field, that means that it will move away from the positive plate. So next, what will happen if the charge from infinity? Let's say we look at the infinity. If a charge kill positive charge, where it's moved from infinity to the distance, where the distance is near to the plate. So what will happen? Let's look at the electric field. The electric field of the positive charge plate. So the direction of the electric field is to Right. The direction is from the positive charge plate to right side. Now we look at that. If there is an electron from infinity, if the electron from infinity, where is moved, the electron from infinity move near to the a region where in the electric field, where the distance, that means that it will move to a certain distance. After that, it will repel away. Why repel away? Because the positive proton is positive charge. The proton with positive charge, where the charge plate also positive and positive will produce a repulsion force. The repulsion force will push the positive charge away from the charge plate. Okay. Then, how about electron? If electron, what will happen? So same thing, if the electron is pulled to the positive charge from a distance of infinity, the negative charge, negative electron will straight move into the positive charge. So from here is the electric potential at, let's say, we just now is the electric potential at point P, positive or negative, because the positive charge is positive charge, right? Electric potential at pole P is positive. And how does the kinetic energy of the proton vary as it approaches the point P? So this means that just now we noticed that the positive charge will move near to the flat charge, and then it will stop at a point P, right? When it stops at the point P, this means that stop, no more kinetic energy. That means that initial moving, right? Moving, that means that with the kinetic energy. The proton with kinetic energy at the end stop. That means that the kinetic energy decrease. If the kinetic energy decrease, what happened? That means that the potential, electric potential energy of the proton will increase. Where the second animation, how does the kinetic energy of the electron? The electron, when it approaches the point P, that means that it will move straight to the point, to the plate, positive plate, right? That means that it moves faster and faster, and the kinetic energy increase. How does the electric potential energy of the electron vary as it approaches the point P? So this means that the electric potential energy will decrease. Ladies and gentlemen, you notice or not? For the proton, if the kinetic energy decrease, meanwhile, the potential energy of the proton will increase. If the kinetic energy of the electron increase, the electric potential energy will decrease. That means that the kinetic energy and the potential energy, okay, one increase, one decrease. That means that it's inversely proportional. Why? Because the kinetic energy will convert to potential energy. Or potential energy, the loss of the kinetic, the loss of the kinetic energy convert to potential energy, which is obeys the principle of conservation of energy. Okay. So next, okay, if we change, just now it's a positive plate, right? Just now it's positive. Now we use negative charge plate. If negative charge plate, meanwhile the electric field, the direction is into the plate. That means now the electric field direction is from right to left. What happened to proton from infinity? So proton will move and go into the negative attract. How about electron? Negative charge, sure, repel. So that means that negative plate, that means it will go to a point P, after that repel. So what happened now is the electric potential at P, positive or negative? Electron, right? Electron just now, right? Okay, because it's negative plate cause that it is negative. And how does the kinetic energy of proton? Proton will, the kinetic energy will increase because it's attracted by the negative charge pair. And how does the electric potential energy of the proton vary as it approaches the point P? As we know that kinetic energy of proton increase, means while the electric potential energy will decrease. And how about the electron? The electron, the kinetic energy decrease because it's at the end, it stopped at the point P and repel in opposite direction. So this means that the kinetic energy of electron decrease, means while the loss of the kinetic energy convert to electric potential energy. Okay, so as a conclusion, the electric potential energy of electron vary as it approach the point P increase. Okay, so it's inversely proportional. Next, the electric potential V at a point in the electric field is the energy required to bring a unit positive charge from infinity to a point. The electric potential energy U, electric potential energy of a charge at a point in the electric field is the energy required to bring the charge from infinity to that point. Ladies and gentlemen, we look at here. Electric potential is V. The potential and electric potential energy is U. So what are the difference? Potential is, okay, we look at here the definition. Let's say at a point in the electric field. Here also at a point in the electric field is the energy required to bring unit positive charge, to bring the charge from infinity to that point, to bring unit positive charge from infinity to that point. What are the difference? Difference is bring unit positive charge. Unit positive charge means, well, that means 1 unit of the positive charge. 1 unit of positive charge, that means that electric potential is the electric energy, the energy required per 1 coulomb of charge. But the electric potential energy is the energy required for the sum of the charge. If 1 charge, that means the electric potential energy will be equal to the electric potential. Okay, if there is 2 coulomb, that means the energy will difference. The energy will higher than the electric potential. Depends on energy is the total energy for the sum of the charge. But for the electric potential is the energy per 1 coulomb of charge. Next, electric potential is a scalar and has unit joule per coulomb, or we are familiar with the unit of watt, where electric potential energy U is a scalar quantity and has a unit of joule.